So in part one, we had talked about two other rules. We had talked about the rules. What rules did we talk? We talked about product of powers and power of a power. And I started to show power of a power and how it looks very, very similar to this. So this says if we have a quantity a times b, this is right multiplication between these two numbers, quantity raised to the nth power, that what we really have is a to the nth times b to the nth power. And it looks lousy, and I know that it does. So let's take a quick look at this, if you don't mind. Let's take a look at it this way. Let's take this. Let's take 6 squared. All right. So we have 6 squared, and we know that's the same as writing 6 squared, isn't it? And 6 squared is equal to 36. Let that be our declarative. Let that be something that we agree on, that 6 squared is 36. So then, what this rule says is, if we take factors of 6, like, I don't know, how about 2 times 3 is 6, isn't it? So 2 times 3, that's 6, isn't it? So all I'm doing is I'm taking this 6 right here and I'm writing it as factors. And now I'm going to take this 2 right here and I'm going to say, so this problem and this problem are the same problem. And they should, when I do this work, it should equal 36, shouldn't it? Now, of course, what you want to do is you want to do 2 times 3 is 6, and 6 squared is 36, but we already know that. What I want to know is, what if we do it this way? What if we do that? So we'd have this. We'd have our 2, right? Our 2. This 2. This 2 is this 2. This multiplication sign is this one. And this 3 is this 3. Is that okay? See this green 2, exponent of 2. I'm going to see what happens if I distribute that. So I'm going to raise that to the power of 2 and that to the power of 2. So that's me distributing. That had darn well better equal 36 if this rule that we are looking at right now, the power of a product rule, is true. So let's see that. We have 2 squared is 4, isn't it? 4. 3 squared is 9, right? And what I want to say to you is, see this multiplication sign right here? It's this one. This multiplication sign is this one. And I want to know, is it true that 4 times 9 is 36? This is not a statement, this is a question. I'm kind of testing this rule up here. This work right here is the test of this rule up here. And 4 times 9, in fact, is 36, isn't it? Try it with a number you like. I don't know. Try it with Try it with 8, maybe 8. 8. So 8 squared. I'm using this exponent of 2 because it's an easy exponent. Frankly, I don't want to. And 8 squared is 8 times 8. This is the same as writing 8 squared, isn't that right? And we know that 8 squared means 8 times 8. And we also know that 8 times 8 is 64. And therefore, 8 squared is 64, isn't it? Okay. So we know this is going to equal 64. And let's break this into factors. So I'm going to rewrite my 8. I'm going to rewrite it as factors. I'm going to multiply. I don't know. What could we do? Oh, look. What if we did this? What if we did this? What if we said it's 2 times 2 times 2? Right? But remember, so this is all right. 2 times 2 is 4. 4 times 2 is 8. So this 8 down here is this 8, right? This is multiplication. Right? And we have an exponent of 2. So now what I want to know is this rule up here that we were just talking about, is this true? So again, I'm going to try to prove that this rule is actually true. So I'm going to prove this rule using simple arithmetic, because I want to know, does this really, really work? So here's the first 2 times the second 2 times the third 2, right? Remember, what I believe is this. I believe that we can distribute this exponent. So we can do here, excuse me, here, and here. So let's try that and see if it worked. So this would be 2 squared. That's this 2 squared. This would be 2 squared. That would be this 2. This would also be 2 squared. That would be this, wouldn't it? 2 squared is 4, isn't it? 2 squared is 4, isn't it? 2 squared is 4. So I'm simplifying all of these. So this is this, this is this, and this is this. And then I'm going to try it. 4 times 4 is 16, and 16 times 4 is 64. This rule actually works. Now, the example they want to show us in the book is, I don't know, it makes some more sense to me now. I didn't like the example they showed us in the book initially, because this is the example they showed us. Their example was this. But to me, I was like, arithmetically, why is that true? So I provide a little bit of proof. I hope they want us to simplify this. They want us to simplify negative 2 x y, and they want this whole thing to the third power. So how are we going to do this? Can you see it? Right? These are the factors. It's this times that, right? So what are we going to do with this 3? Think about it. Right, we're going to distribute it to here, and to here, aren't we? And therefore, when we rewrite this thing, it's going to look like this, isn't it? We're going to have negative 2 x y, and all raised, right? All raised to the third power. So this is negative 2 to the third power, x to the third power, y to the third power. Now, of course, what we can do here is we know that negative 2 to the third power means negative 2 times negative 2, times negative 2. A negative times a negative is a positive, times a negative is a negative, so we have negative. 2 times 2 is 4, 4 times 2 is 8, so negative 8. So this simplifies to negative 8, right? Negative 8 is negative 2 cubed, x cubed, y cubed. So I think that works out good. I love the rule. I think the rule is fantastic. This is a great rule. Remember, though, the rule should be able to be proved arithmetically, and that's what we did, right? We took some simple 5th grade math and applied it to a relatively complex idea, didn't we? All right, can we try some questions? These are the questions from the 3 rules that we've done so far. Let's see what this might look like, okay? So let's simplify a couple of problems, right? So let's simplify here, simplify. And let's take the first one, let's take this one, it's a, b, no, it's actually a, b to the 4th, not quantity to the 4th, right? Times a, b squared. And with this one, what I would like to remind you is this. Check this out just for a second. If you do this, 2 times 3 times 4. I'm trying to prove the commutative property of multiplication. 2 times 3 is 6, times 4 is 24. But what if I didn't do it in the same order? What if I move the order around? What if I did 3 times 2 is 6 times 4 is still 24, isn't it? Or what if I did 4 times 3 is 12? 12 times 2 is 24. Doesn't it work? So what I'm suggesting to you is this. When I look at this problem, this is what I see. I see A, and I see A. And I realize I know how to multiply A times A, so I'll get A times A. Whoops, it's not great. A times A, right? Remember, these things are being multiplied here. So, times, we have a b to the 4th, don't we? B to the 4th, and we have a b squared. I'm multiplying like terms because I know it works out to be. Well, what is A times A, right? If 5 times 5 is 5 squared, and 2 times 2 is 2 squared, and 3 times 3 is 3 squared, then A times A is, right, good job, is A squared. And b to the 4th times b squared, right? That's the first rule that we looked at today, isn't it? It's the first rule that we looked at today, which was product of powers, right? And we get b to the 4 plus 2 was b to the 6th power. Isn't that right? Okay. Let's try another example. Another question out of the book. And the question is this one. I'm just taking these. How about this? The quantity, this is example 2. The quantity 9p q to the 7th, all raised to the 2nd power. So I'm going to put this out here. So here's my question. What are we going to do with this? What rule are we going to use here? What can we do? And hopefully we know that we have power of a product rule here. And what are we going to do with this 2? Can you see it? What are you going to do with this 2? Hopefully, right, you realize you're going to multiply it times this, right? And this is p to the 1st power. I'm going to multiply this here. Multiply this here. Just to be clear, multiplying exponent times exponent, right? So when we work that out, that will give us, look at this, it will give us 9, right? This is 9 to the 1st power, right? 9 to the 1st. So 1 times 2 is 2, so 9 squared. This is p right here. This is p to the 1st power right here, isn't it? 1 times 2 is 2, isn't it? And we have q to the 7th. So we have 7 times 2 is 14, right? We can simplify this out just a little bit more because we know that 9 squared is equal to what? 9 times 9 is good. 81. P squared Q to the 14th power. So hopefully that's working out really good for you. Let's try let's try this one here. It's kind of weird looking. I like this. Let's try this as our last example before we wrap this video up. What if we take this problem like this? This is actually, I love this problem, is 4 squared, quantity to the third power, the whole thing raised to the second power. Now this looks terrible, but if we look at this rule for a second, what are we allowed to do here? What are we allowed to do here? Think about this for a second. Actually, stop the video for a second. Try to work on this and see if you can't figure out what you'd like to do here. I think I know what I want to do, right? I think I want to use power of a power, don't you? So I'm going to work outside in. 2 times 3 is 6. 6 times 2 is 12 equals 4 to what, right? The base is 4, but 4 to the, do it backwards. 2 times 6 is 12. 12 times 2 is, I'm sorry, that's not true. 2 times 3 is 6. 6 times 2 is 12. 4 to the 12th power. And if you're sitting there going, but I don't know what 4 to the 12th power is, neither do I. All we're trying to do is simplify, right? We're trying to write this in exponential form, right? So we just simplified this, okay? We could have done this math. This is a huge number. It's absolutely huge. And I don't know what that value is, but here we go, all right? So that gets us through chapter 8.1, I hope, all right? Hopefully you're taking good notes and you're trying your homework and you're doing lots of examples and you're giving me some comments and telling me how I can help you more.